everyone. So today we're going to take what we practiced yesterday, so the notes from yesterday, and we're going to do two problems using those techniques. This is going to count as an assignment grade for you guys. So it's two problems. I am going to work them out for you, but the video is going to pause every few minutes or so and ask a question. And that's what your grade is going to be based on, whether you get those questions correct. Now, also please answer them carefully because you do only get one attempt at this. So let's look at our first system. I have the quadratic equation y equals x squared plus 4x minus 2 and the linear equation y equals x plus 2. And I went ahead and I graphed them so that you can see a visual representation of what it's going to look like. There is our quadratic, and then there's our linear. So obviously you can see that they are crossing at 2 points, and you can pretty much already tell what these solutions are going to be, but I do want you to be able to solve this algebraically. So let's take a look at what we have. Since both of them are set up as y equals, it makes it pretty easy to replace one of these y's with an entire expression. So that's what I'm going to do. Replace this y with this entire expression. So this will turn into x squared plus 4x minus 2 is equal to x plus 2. Now, because of that x squared, this is a quadratic equation, which means that in order to solve this, I need to make it equal to 0. So we want to move this x over to the other side and this 2 over to the other side. So minus x, and I'm lining it up. Minus 2 and minus 2. So I know for sure on the right side they're going to cancel out, but let's take a look at the left side. That would leave me with x squared plus 3x minus 4 is equal to 0. Okay, now let's factor that quadratic equation. So what I'm doing now is I'm looking for two numbers that when I multiply them, multiply to -4, but add up to 3. So on this side we're multiplying, this side we're adding. Okay, so 4, you could either have 1 times 4 or you could have 2 times 2. But because this is not just regular 4, it's -4, that means that one of your numbers has to be negative in each pair. So I kind of already know the answer, so I'm going to make the first numbers be negative, and let's see what happens. Well, -1 plus 4, that already gives me my 3, so the first one worked out. -2 plus 2 would be my 0, so that doesn't work. So when I factor this, I should have x minus 1 and x plus 4. And now we're going to set each one of those factors equal to 0. So x minus 1 equals 0. I would have to move that -1 to the other side of the equal sign, which leaves me with x equals +1. Okay, do the same thing to the other factor. X plus 4 equals 0. Move the 4 over to the other side, and that leaves me with x equals -4. So I have my two x values. I need to go back, and now I need to find the y values that correspond with each of these. So what we're going to do is we're going to take one of our equations from the original system. So see how we have two equations? You only need to pick one of them, and it's obviously always going to be easier to pick the linear one. So y equals x plus 2. But we're going to replace that x with whatever value we had. So in this case, we had 1, and that gives me y equals 3. Now with the other one, but we're replacing that x with a -2. Or I'm sorry, -4. And that gives me -2. So remember that these x and y values correspond with each other. So this x goes with this y, making the solution 1, 3. this x matches with this y, making the solution -4, -2. So those are the two solutions to our linear quadratic system. And let's take a look at the graph. And sure enough, 1, 3 is this one here. And -4, -2 is that one there. Okay, now let's take a look at our second system. This time I'm going to be asking you to answer questions before I show it on the screen. So I have the quadratic equation, y equals x squared minus 4x, and then the linear equation, y equals -2x plus 3. Again, I went ahead and graphed it for you guys. So here's our parabola, and then here's our line, and as you can see, it crosses twice. Once here and once here. So we're going to have two solutions when we're done. Let's start by doing our substitution. So what I'm going to do is plug in this quadratic expression here into the y here. So let's rewrite this new equation as x squared minus 4x is equal to -2x plus 3. Now we're going to move both terms from the right side over to the left side because we want this to equal to 0. Opposite of -2 would be plus 2x. So we're going to do that to this side as well. And then opposite would be -3. And as you can see here on the left side, there is no constant term. There's x squared, there's x, but there's no number. So that -3 is going to go here at the end. So it cancels out, cancels out. What am I left with? So that'll be x squared minus 2x minus 3 is equal to 0. Our next step is now to factor that resulting quadratic equation. So I'm going to draw my t-chart here to the right side. And we're looking for numbers that will multiply to -3, but add up to -2. So 3 is a prime number. There's only one way to multiply it. That's 1 times 3. But we need it to be -3. So we're going to have to make a decision. I'm going to write it down twice. Which number has to be negative? Is it going to be the 1 or is it going to be the 3? So the way we're going to find out is which one adds up to -2. So which one do you think it's going to be, guys? Which one should I pick? So let's take a look. -1 plus 3 is +2. So close, but that's not it. 1 minus 3 gives me -2. So that's the one that I want to use. So my factors are going to be x plus 1, x minus 3, and then still equal to 0. Now we're going to set each one of those factors equal to 0. X plus 1 equals 0. So that means that x equals -1. And for the other factor, x minus 3 equals 0. So this means that x is equal to +3. Now we need to find the y values that go with each of these x values. So to do that, we're going to go back to our original system, and let's use that linear equation. Y equals -2x plus 3. Only we're going to replace that x with the values that we just found. So this would be y equals -2 times -1 plus 3, which means that y equals 5. And for the other one, we're going to use our same linear equation, so -2x plus 3. But let's plug in 3 for our x value, which means that y equals -3. So now, each of those values get paired up. This x matches with this y, making the solution -1, 5. This x matches with this y, making the solution 3, -3. So if we look at our graph, let's see if we were right. So this point up here, that's our -1, 5. So we did good on that one. And then this point down here, that's our 3, -3. So again, we found exactly the 2 points where it intersected. Okay guys, like I said at the beginning, this is going to count as an assignment grade. Please make sure that you answered every single question, and if you have any questions for me, let me know.